Hello, I am Dr. Sigar Kanti, Associate Professor of Mathematics, Government First Year College, KR from Bangalore. In this video, I am going to write Python program to expand a function of two variables using Maclaurin series expansion. So, what is Maclaurin series expansion? Any function f of x comma y can be written as f 0 comma 0 plus 1 by 1 factorial into x into fx 0 comma 0 plus y into fy 0 comma 0 plus 1 by 2 factorial into x square fxx or fx square we write 0 comma 0 plus 2xy fxy 0 comma 0 plus y square fy square 0 comma 0 plus 1 by 3 factorial into x cube x cube, that is third derivative with respect to x at again 0 comma 0 plus 3 x square y, here f x square y 0 comma 0 plus 3 x y square f x y square 0 comma 0 plus y cube fy cube 0 comma 0 plus and so on. This is our Maclaurin series expansion. So what we have to do is, first we have to find out the derivatives, that is the fx, fy, fx square, fxy, fy square, fx cube, fx square y, fxy square, fy cube, and if we consider the fourth order derivative, then we have to go for plus again 1 by 4 factorial. Okay, this is x raised to 4 fx to the power of 4 0 comma 0 plus and so on here, and these coefficients are binomial coefficients here. This is our 3c0, this is 3c0, 3c1, 3c2, and this is our 3c3. Okay, binomial coefficients. So to write a function, first we have to find out the derivatives. Okay, see here, this is our f00. This is differentiated. This is differentiated with respect to x and y 0 times. Okay, and fx means this is differentiated the function f with respect to x 1 time and with respect to y 0 times, and this is differentiation of f with respect to x 0 times, with respect to y 1 time. And if I come to this one, fx square is, this is differentiation of f with respect to x 2 times, and this is differentiation of f with respect to 1 time, that is second derivatives, with respect to x 1 time and with respect to y next time 2 times. And fy square means differentiation of f with respect to y 2 times. Okay, and similarly we go for this one, third derivatives, fx cube, differentiation of f with respect to x 3 times, x square y, derivative of f with respect to x 2 times and with respect to y 1 time. Next, this is derivative of f with respect to x 1 time, y 2 times. Okay, so that means here, so this is without derivative. That means we are not differentiating. So we write this as, we can write this as differentiation of f with respect to x 0 time, with respect to y 0 time. Okay, and here these are the first derivatives. Okay, first derivatives fx and fy. Okay, and these are second derivatives, and these are the third derivatives. And if we see the powers in the first one, x 1 time, y 0 time, 1 plus 0 is 1 here, x 0 times y 1 time, 0 plus 1 is equal to 1. Okay, similarly here x 2 times, okay, 2, and here x 1 time, y 1 time, this is 1 plus 1 2, x 0 times y 2 times, 0 plus 2 is 2. So here x 3 times y 0 times, 3 plus 0 is 3. This is x 2 times y 1 time, 2 plus 0 is 2 plus 1 is 3. This is x 1 time y 2 times, 1 plus 2, this is equal to 3. These are the third derivative, and the final last one here x 0 times y 3 times. That means here the number of times of with respect to x plus number of times with respect to y in this third derivatives is, this is 3 plus 0 3, 2 plus 1 3, 1 plus 2 1 plus 2. Okay, this is also equal to 3, and y cube means x with respect to with respect to x 0 times, with respect to y 3 times. What I do here is first we find out these derivatives, that is first order derivatives, second order derivatives, third order derivatives. I have considered only 3 degree terms here. That means I have to find out first f0 0. That means here I will write this as f0 0, means this is our differentiation of f with respect to x 0 times, with respect to y 0 times, and at the point, next we write the point x equal to 0, y equal to 0, and next we find out so fy. I will write this as like this, f0 1, okay, with respect to x 0 times, with respect to y 1 time, that is, this is our, we write like this. Okay, and next to fx with respect to 0 times, y with respect y 2 times, and next f x 0 times, y 3 times, right? And next to with respect to x 1 time, so this is our f x, I write this is x 1 time, x 1 time, y 0 times, that is x with respect to x 1 time, with respect to y 0 times. Next we write f 1 1 with respect to x 1 times, y 1 times, and next f x y square. Okay, so with respect to x 1 time, and with respect to y 2 times, 1 plus 2 is this is x, okay, 3 times, and we stop here, we are not finding this one. And then we go for f 2 0, that x 2 times, y 0 times, f 2 1, f 2, okay, we stop here. Okay, that is here this one f derivative of f with respect to x 2 times, with respect to y 1 time. Okay, and we write f x cube, x cube means we write 3 0, that is with respect to x 3 times, with respect to y 0 times, f 3 0. Okay, so we are not finding this one. That means here we are finding f at x equal to 0, y equal to 0, and we are finding fxy, we are finding f, so this is not fxy, this is our just y, this is fy square, this is fy cube, fxy, fx, this is our fx, this is fxy, this is our fxy square, Okay, and this is our f x square y. Okay, and this is f x cube. Okay, these we are finding these, and we put them in a matrix formation, matrix form. So here we write this as are these elements in a matrix 1, 2, 3, 4. 4 rows are there, 4 columns are there. Okay, 4 by 4. And here we are considering up to third order derivatives. Okay, third order derivatives. If we consider third order derivatives, I will make I will create one matrix of order 4 into 4, and I will call this as a y. Okay, and this is nothing but y00, and this is nothing but y01, that is 0th column, 0th row, first column, and I will write this as y02. I will write this as y03. Okay, similarly if I come to this one, I will denote this, this is nothing but our y10, and this is y11, and this is our y12. Okay, and this is nothing but y20, y21, and this is our y30. Okay, so that means here all the derivatives I am keeping in some place of the matrix of order 4 by 4. So here to find this one, I will use one for loop, and in that first part I will find out all these derivatives and I will put in the matrix form. This is one part. And second part, as we have in the second part, I will try to find out this sum here. So initially I will take sum is equal to this quantity. So that is here f00. Okay, first I will take this quantity. So that is here I'm sorry. In the second part, what I do here is fxy is nothing but f00 plus 1 by 1 factorial into x into fx plus y into fy at the point 0, 0 plus 1 by 2 factorial into x square fx square plus 2xy fxy plus y square fy square plus next term 1 by 3 factorial into x cube fx cube plus 3x square y fx square y plus 3xy square into fxy square plus last term y cube into fy cube, and if you want you can continue with the next term. See here I will take initialize, say s is equal to f, that is f00 initially, and then I will use one for loop here. I will take I from 1 to say n. N means that is I already have taken that as the order, the derivatives. So here I have considered up to third order derivatives. Okay, so I equal to 1, I equal to 2, I equal to 3. So I will take I will use a for loop here, for loop, and in that for loop I will take I is equal to 1 to 3. 1 to 3 means I have to use I in range 1 comma 4. That I take the value 1 2 3 1 2 3 1 2 3 because I have taken last term is equal to 4 here, means I take the value 1 less than 4, and then I will find out first time I will take s is equal to f0 comma 0. First time I will add this term. Second time when I equal to 2 I will add this term. Third time when I equal to 3 I will add this term. Finally we get the sum here. And within that, when if I take I equal to 1, see here this something I have to calculate here. So within that for loop I will use one more for loop to calculate xfx plus yfy, and when I equal to 2 I will use one more for loop within that to find this quantity, and I becomes 3, Then I will use one more part within that, so to find this quantity. Okay, so totally two parts are there. First part is to find the derivatives, putting in that in the form of a matrix. Second part I have to use a for loop. Within that one more for loop to find the sum. Okay, let me write the program. Let me write the program. Okay. First I will we can give any comment line. I am not going to give comment line here. We use we have to import, because we are using differentiation, therefore we have to import SymPy. From SymPy import star. Okay, and then we have to use x and y as the symbols here. X comma y equal to symbols x comma y quote close bracket close, and if you want you can take a and b also here, comma a comma b. This is for if you want to expand the function in Taylor series around x equal to a, x equal to b. Okay, so here we can give, I am not using in Maclaurin series, I am not using a and b. Okay, so just we are declaring that they are also the symbols, and then I will take the number, the order of that derivative here. N equal to, I will take the, write that as n equal to int input how much degree we can give question mark here, how much degree, okay, quote close bracket close, and I think one more bracket I have to close. Okay, and then I will create one matrix here. So let me write that matrix as a capital Y equal to n plus 1 by n plus 1. If the order is 3, if I need the order 3, then I have to create 4 by 4. That is zeros, 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 say n plus 1, created the matrix 0, Y, and then I have to give the function. What the function f of x comma y, f of x comma y colon return. So in this case I am considering the function as e power of x into log of 1 plus y, e power of x, that is exp x bracket close into, that is star, log of 1 plus y. This function I have to expand. This is a function of two variables. Okay, then here first, in the first case I will find out the derivative, and I will keep them in the form of a matrix, that is for I in range n plus 1. So you can use 0 comma n plus 1 or just n plus 1. By default it start with 0. Okay, n plus 1, and then for j in range 0 to n plus 1 minus I. Okay, so this is because we have, if second derivatives are there, then the total number I plus j must be equal to 3. If I use if I want only up to 3 derivatives, then in the third derivatives, x with respect to 0, y with respect to y, x 0 times, y 3 times, or x 2 times, y 1 time, or x 2 times, x 3 times, y 0 times, like this. Okay, so if I is 0, then corresponding j takes value from 0 to n plus 1 minus I. Okay, then colon. Okay, next I am creating a matrix here. Say y, I have already created a matrix with 0 elements here. I will update those elements. Y I comma j equals differentiate. I have to differentiate twice. Differentiate and differentiate this f of x comma y, x comma y with respect to x I times. Okay, and with respect to y, comma I have to put here, comma with respect to y, how many times? J times. Okay, differentiate f of x comma y, x I times with respect to x I times, with respect to y j times. Okay, and then I will find these values derivatives at x equal to 0 and y equal to 0. So that is here y I comma j equals y I comma j dot substitute substitute open bracket open flower bracket x equal to 0, that is x colon 0 comma y colon 0 flower bracket close and parenthesis close. So that means first we find the derivatives, and I'll keep that in the name of y 0 y 01 y 02 y 21 23 like this. Okay, and we are finding those values when at x equal to 0 y equal to 0. This is needed. Okay, then after this is what this part is to find this part is to find the derivatives at x equal to 0 y equal to 0. So next part is I'll go on finding that, expanding the function. So initially I'll take s is equal to y 0 comma 0 initialization, and I will use for loop here for I in range 1 to n plus 1, that I takes the value from 1 to n. I have to write n plus 1 colon. Then within that, see here, I equal to, this is initialized. I equal to 1, I will get this. I equal to 2, I will get this. I equal to 3, I will get this. And again within that, I equal to 1, I have to find out this quantity. So I have to use one more for loop here. And then after that, if I becomes 2, then this is the value. And within that, so I have to find out this one. Okay. So we have to write one more for loop within that for loop. Right. So within this, what I do here is I will take one more variable s1 equal to 0, and next for j in range j in range 0 to I plus 1 0 to I plus 1 colon s1 equal to s1 plus binomial I comma j star x double star I minus j star y to the power of y double star j into, that is star, derivative, that is y, y, I minus j, I minus j, I minus j, comma j, okay, comma j. So this is this for loop is to find these values, okay, this value, this value, and this value. I equal to 1, first time I am finding this one. I equal to next time I am finding this one. I equal to 3, next time I am finding this one. Then what I do here is this value plus that got value divided by I factorial plus this value divided by I factorial when I equal to 2. Then I becomes 3. I take this value divided by I factorial, okay. Then after finding this, I'll find out S. S is equal to previous S plus S1 by factorial I. Alright, now we have got all these stuff. I from 0 to here, I to 0 to 3, I equal to 1. First I will find out S1 by 1 factor. S1 means that x into fx plus y into fy, and I becomes 2. Then this is nothing but, S1 is nothing but x square, okay, x square x square plus 2xy fxy plus y square fy square, right? Then finally I am going to print this. Print Maclaurin's expansion is Maclaurin's, okay, I have to write put a single quote or double quote. If I put double quote, here I will write a single quote. Maclaurin's expansion is, okay, here we can give slash, backslash, no, it is not backslash is, okay, backslash n. This goes to the next line, double quote close, comma, yes, okay, close. Now I think everything is correct. Let me run this program. How much degree? So let me take degree equal to 3. I will type 3 and press the enter button. So this is our Maclaurin's series, okay. Next, I will go to another example. Cos x cos y. Consider, and see, I am not using a and b here. We can remove these x and y, okay. Next I will consider cos x cos y. So where I have to change? Here I have to change. Return function is there now. So here I write return cos x, cos bracket x, star cos bracket y, okay, sorry, cos y, return cos x cos y. Remaining things are same, okay, everything is same. Just I have to change the function. Running this, okay. Again, how much degree terms? If I say 4, I am getting this, okay. And same function, okay, let me say if I take 2, I am getting this. And 1 is 1. Okay. Next I can go to one more example. E raised to x into cos of by. E raised to e power of x, that is exp bracket a star x star cos by, cos b star y. Okay, this is our function, and here these functions involve a and b. What are those a and b? There must be symbols, therefore I have to include here comma a comma b. Here I have to write comma a comma b. Okay, remaining thing is same. Run. Again, for as per degrees, let me write 2. So this is our expansion. And if you don't give a and b here, okay, let me check what happens. If I run this program, say 2, yeah, a is not defined. So therefore I have to define a and b as symbols, or otherwise we have to give some values to a and b. Next I will go for another example. Log of 1 plus x plus y. Log of 1 plus x plus y. Run. So here no problem, a and b are not there. Running this program, how much degree turns it asks, just 2 or 3. Okay, press enter button. This is the expansion. One more example, cos of x plus y. Just we have to change the function, cos of x plus y. Okay, just run, and again it asks for what is the how much degree terms. If I take say 3, type 3, press enter button. Okay, so this is the expansion of cos of x plus y. Okay, thank you. I will stop here.